Sige, let us start. Let's have a little review about titration. This was our topic last time, right? Last week. So again, do not forget class, when we are doing titration, most likely we are doing standardization. Meaning, we are determining the concentration of our prepared solution. So in the laboratory, it's not just about preparing chemicals or solutions. It is also important for us to know what is the concentration of our chemical substances or our prepared solution. So in doing the titration, we have to take note of some terminologies, like when you say analyte, that is our sample, or that is the constituent of our substance that is being measured or identified. Okay, that is titration, ha. And in the laboratory, what we did was volumetric titration, meaning we are determining the concentration through reading or measuring the volume of a solution with known concentration. Ito yung ginawa natin sa laboratory. Though other types of titration also exist, like gravimetric titration, like we are measuring the mass naman, the mass of the reagent, or colorimetric titrimetry, wherein we measure the time required for the complete to complete the electrochemical reaction. Okay, so that is measuring actually electrical current that will consume the analyte. Okay, so this is, don't forget, our next. This is our titration setup. Please be familiar with the different laboratory apparatuses that we used for titration. Burette is the most important one, and class, the substance being added through a burette is called a titrant. Okay, again, it's called a titrant. Okay. So again, our analyte is our sample, and then again, in using the burette, it is not really necessary to fill the burette up to the 0 mark, kasi you can always do the initial reading. You can always read the initial reading, and then after titration, after reaching the end point, you may also have the final reading and then subtract the two so that you can get the volume of the titrant being used in titration. Okay? So I hope that is clear. Now, another one, we have the so-called back titration class. Back titration is synonymous to our indirect or residual titration. So this is where we have one analyte still, but we will have two titrants. Okay? Dalawang titrants dito. Yung ginawa natin sa laboratory, one analyte, one titrant lang yun. So we call that direct titration. Okay, direct titration lang yun. So we do back titration if, for example, the reaction will be slow, hindi agad-agad magre-react si titrant and si analyte. And if, for example, there are problems with the properties of our analytes, like it's not really soluble to our solvent, so especially if our analyte class is solid and then we need to dissolve it first sa tubig. Now, if it's not really soluble to water, then we will have problem with the direct titration. And it's that time we will be doing the indirect one. Okay? So, standard solution, yung solution class ha, na alam natin ang concentration. Okay? If we know the concentration of the solution being used in titration, that's the standard solution. So most likely, we also call this the titrant if we are going to add it using a burette into the sample or the analyte. Equivalence point is only the theoretical point, and this is where we assume that there is an equivalent amount of titrant and analyte that has reacted. Okay. And then the endpoint is the one that we see during the actual experiment. This is where there is a change in color in our solution through the addition of our test solution, our indicator. There is a physical change in color. So again, our indicators, here are our examples, our acid and base indicators where they are going to change in color depending on the environment. So they have different color when you place them in an acidic environment, and basic environment naman, different color na naman sila. Okay? So ayun sila yung reason why there will be changes in color during titration. Okay? So be familiar with the different indicators that we can use depending on what we are titrating. Like if we have a sample that is a strong acid and we're going to titrate it using a strong base, a standard solution, a strong base, then we can use either the methyl orange, methyl red, or the phenolphthalein. Okay? Daanan lang natin ha, and then we will concentrate with the problem solving. And then primary standard class, these are chemicals that are considered very pure and very stable that we can use during the titration process. And how do we differentiate it with the secondary standard? The primary standard is most likely solid. So just like our potassium hydrogen phthalate, we use that one in the laboratory. Diba? For the experiment number 11, that's acid-base titration or the preparation and standardization of the sodium hydroxide solution. We used potassium hydrogen phthalate, for the determination of the concentration of the sodium hydroxide. So in that case, class, although the sodium hydroxide is our analyte, it has become actually the titrant during the process since we used a primary standard. Again, a primary standard is a solid substance which is very pure and can be used during volumetric and even mass titration. These are the requirements of the primary standard. Ayan. Number 1 talaga is highly pure siya. So we only have limited number of primary standard in the laboratory since maraming requirements ang kailangan i-satisfy before we can really use them. What we have in the laboratory is most of the time secondary standard. So again, ito naman yung liquid. Liquid na naman ito to be used during the titration process. So when you say secondary standard, we know the concentration actually here. So syempre, the example is yung ginawa natin experiment number 12, preparation and standardization of the hydrochloric acid solution. Wherein our sample there was syempre hydrochloric acid. Yun yung hinahanapan natin ng concentration. And yung prepared nyo na sodium hydroxide has become the titrant. It was considered as the secondary standard. So do not forget, secondary standard are solutions used to titrate your analyte, but you have to take note that the first thing you have to know about your secondary standard is its concentration. That is the reason why you cannot really perform experiment number 12 sa laboratory without performing experiment number 11. Okay? So now we are entering sa problem solving of this topic, establishing the concentration of standard solutions. But do not worry, since even in your Chem 101, we already had the computation of the concentrations of the solution. We will just go back a little bit about normality and molarity. Ito pa rin yun, molarity and normality. I am just hoping by this time you are very much familiar with our formula for both molarity and normality and paano natin siya kino-compute. Especially with normality, that you have first to look for the milli-equivalent weight before you can really compute for the normality. So please go back with your normality and molarity na lesson. Anyway, we'll discuss and we'll just have different set of problems. We'll just introduce sa inyo different set of problems today. But let's discuss first, how do we establish the concentration of our solutions? Pwedeng our standard solutions or any other prepared solutions in the laboratory. We have two basic methods, the direct method and the standardization. So when you say direct method class, ito yung kuha lang tayo ng ating substance, solid substance, and then directly dissolve it in a given solvent. Given solvent has suitable na solvent. And then just compute directly the either the normality or the molarity. Let me just connect my pen so that I can write on the screen. Let me try. Okay. So again, when you say direct method, it is where you have a specific amount of your sample, like you get 1 gram of sodium hydroxide and then dissolve it. For example, our suitable solvent for sodium hydroxide is just water. So like you dissolve this in 100 ml solution, automatically you can compute for either the normality and the molarity. That is why we call it a direct method. So just use the normal in our original formula for this. Molarity is moles per liter and normality is weight of the substance over volume times its milli-equivalent weight. So using this information like 1 gram of sodium hydroxide, ay, nasobraan yung aking arrow. Ayan, gamitin mo yan siya for the weight of sample if you're computing for the normality and you're going to use the 100 ml for the volume and just compute for the milli-equivalent weight of sodium hydroxide. That's direct method. Directly measuring or computing the concentration of the prepared solution just by using its weight or amount in grams and also the volume of the solution being prepared. That is also true for the molarity. You can always compute this one. The 1 gram or the amount in grams can be used. You just have to convert it into moles first. And then convert this one into liter. You can also compute for the molarity. That's direct method. You just have the amount in grams, most likely in grams, and then dissolve it in a suitable solvent. Just measure the amount of the solution in volume or in ml or in liters afterwards so that you can do the computation. Okay, again, that is called direct method. But what we did in the laboratory when we prepared both our sodium hydroxide and hydrochloric acid was called standardization. Okay, standardization is done through titration class. Di natin agad-agad malalaman ang concentration of our prepared solution just by doing the direct method. In the first place, we don't have the amount in grams in that. And then, ang tawag doon, especially for hydrochloric acid. Okay, again, especially for hydrochloric acid. And for sodium hydroxide, we cannot really have the direct method since sodium hydroxide is considered hygroscopic. Again, the term is called, let me write it in the screen, hygroscopic. Anong ibig sabihin ng hygroscopic? Hygroscopic substances are those that absorb moisture coming from the environment. So remember class, sa air natin, we have water vapor and hygroscopic substances are able to absorb that. And when they absorb that, syempre magkakaroon sila ng liquid, ng water sa kanilang formula sa kanilang chemical structure, and that will lead to either it's mag-moist siya or mag-liquefy talaga siya. I'm not sure if you have observed that during our laboratory class or kung sa class ni Ma'am MJ for the other group. But if you observe that class nakita niyo doon na after some time na you left the sodium hydroxide pellets na walang closure, walang takip yung kanyang container, nag-liquefy siya. So, hindi basta-bastang gagamitin si direct method doon. Kasi masasama dapat sa computation natin yung amount ng moisture na kanyang inabsorb. Okay, from time to time, even if the sodium hydroxide has been prepared as a solution, it has the ability, it still has the ability to absorb moisture in air. So actually, for sodium hydroxide, the instruction before using is to standardize it first. Standardize muna before using, before using the sodium hydroxide. Okay? So again, for standardization, this is through titration. It's determining the concentration of a prepared solution through titration, either using a primary standard, a solid substance like what we did with the sodium hydroxide using the potassium acid phthalate, or using a secondary standard or a liquid substance with known concentration. And then again, just like we did with our hydrochloric acid, ginamit natin doon secondary standard. Kasi alam na natin yung concentration ni sodium hydroxide, and gagamitin natin yun to determine the concentration of our hydrochloric acid. You have questions before we'll proceed? Or clarifications? Let me just drink water. May hindi ba naintindihan doon? Wala? Sige. So, most of the time, class, in expressing the concentration of our standard solutions or even our prepared solutions in the laboratory, we're going to use molarity and normality. We seldom use percentage, though percentage is also an expression of concentration. Again, most of the time, it's molarity and normality. And you can see that in the laboratory, in the stock room of our laboratory class, most of our chemicals there are expressed either in N or in M. Okay? Before the name of the chemical, may nakalagay either 1M or 1N or kung ano man yung kanilang concentration. So do not forget, molarity is our number of moles per liter of solution. So balik-balikan natin ang ating formula. Molarity is moles of the solute. This is referring to the solute, and then over liters of solution. Okay? So before you can proceed, do not forget to convert weight in grams into moles first. Since we don't have any laboratory equipment that would measure moles, we will just convert it from the grams. Kasi yun yung meron tayo. Our balances, our analytical balance. So let me write also the formula for the conversion. Wait lang. Moles is equal to the weight of the substance. This should be in grams divided by its molar mass. Okay, divided by its molar mass. And do not forget, if I don't have instruction about the molar mass, kindly just round off the atomic weights to the nearest whole number. I want us to be uniform. Okay? And then we have normality. Si normality naman, number of equivalents of reagent in the same volume. Okay? In titration, we assume, class, that the number of equivalent of the analyte or the sample after titrating will be equal to the number of equivalent sa standard reagent, whether it is a secondary standard or a primary standard. Yan yung ating ina-assume for titration process. Mag-i-equal yung kanilang equivalent weights after both the sample and the standard solution. So for the normality, we will be using this formula. Weight of the substance, this is in grams, divided by the volume. If the volume is in ml class, please use, this is in ml. Please use the milli-equivalent weight, okay? But if the volume is in liters, this is still in grams, pero the volume is in liters, you have to use the equivalent weight. Okay? So, in computing the milli-equivalent weight, balikan ko muna lahat ng formula natin before tayo mag-proceed talaga sa ating computation para isahan na diretso tayo sa ating computation. Okay, milli-equivalent weight is equal to the molar mass over the F times 1,000. Pag equivalent weight, alisin mo lang yung 1,000. So over the F lang. F is also known as the equivalence factor. Okay, equivalence factor. And that is depending on what type of compound are we going to determine. Kung acid siya, you have to look at the number of replaceable hydrogen. Again, for acid, you will be counting the replaceable hydrogen. For basic substances, for our bases, you have to count the number of replaceable hydroxides. And lastly, if it's not a salt or nor a base, then it's if it's not an acid nor a base, you consider that as a salt. And you have to look at the total number of positive or negative charge. Okay. Ayan na. So let us start with our volumetric calculation. Starting with this problem, calculating the molarity first. Describe the preparation of 5 liters of 0.1 molar sodium carbonate from the primary standard solid. Okay? Paano daw natin ipe-prepare yung 5 liters of a solution with a concentration of 0.1 molar. Again, that is for sodium carbonate solution. So, anong gagawin? If you encounter this kind of problem class, syempre this is molarity. So, kay molarity yung ating gagamitin na formula. Remember, our molarity is equal to mole per liter of solution. Okay? Again, dito tayo mag-start. Kapag ang question is describe the preparation, you really have to describe it. You really have to write the step-by-step procedure on how to make this solution. But, ano yung problema natin dito? Bakit may kailangan computation na involved? Kasi hindi natin alam kung gaano karaming sodium carbonate yung gagamitin natin to prepare this kind of solution. So definitely, what is missing here, kasi na yung pen ko, ba tayo ng, ayan pala siya. What we are looking here, class, is the weight of our sample in grams. Ayan yung hinahanap dito. Okay? So, ano natin yun hahanapin? Pabaliktad dito na problem ha. So, first thing is we have to compute for the number of moles. So, for the molarity, that's 0.100. Let's just use moles per liter ha, again, so that we can cancel properly our unit. Moles per liter. And then again, we are looking for moles first before we can proceed with the computation of the weight of substance. And then the liter of solution, we have here 5.00 liter or simply 5 liters. Okay? So ayan, I have substituted na all the given in the problem. And then again, we are looking first for the moles. So cross multiply this one. Baba natin si moles. And then this will become 0.100 moles per liter times the 5.00 liters. Cancel this one. Oops, I don't have my calculator here. Here's my calculator. Let me just use my phone first. So 0.1 times 5 liters, that is 0.5. Okay. This is 0.5 moles. Okay? So, ayan na. And then, remember class, sabi ko nga kanina, we don't have any equipment in the laboratory that will measure moles. So, mini-measure talaga natin sa lab is ang weight. So, gamitin natin yung isang formula na binigay ko kanina. Moles is equal to the weight of the substance in grams divided by its molar mass. Since we have computed for the moles already, what we are looking here automatically is the weight in grams. That is divided by the molar mass. Now, this is sodium carbonate. We have to compute first for its molar mass. We have to list down all the elements, sodium, carbon, and oxygen. Identify the number of atoms, 2, 1, and 3. Multiply natin sila each sa kanilang respective atomic weights. A whole number lang muna ha. This is 23, so 46. This is 12. And this is 16, so this is 48. 8 plus 2, 6, 10. Carry 1, that's 106. So this is our molar mass for sodium carbonate, 106 grams per mole. Okay? Again, that's 106 grams per mole. So yan yung gagamitin natin dito for the molar mass. Then, just like what we did a while ago, let's do cross multiplication. Baba natin si weight in grams. This will become 0.5 mole times the 106 grams per mole. Cancel the moles plus what is left is the grams. So 0.5, calculate, you know, nitrous issues. 0.5 times 106 is 53 grams. So 53 grams of sodium carbonate. So how are we going to answer this problem? Kasi describe daw the preparation. Ano ginagawa natin? This is actually a direct method ha. Direct method ito. This is not a standardization method kasi walang titration dyan na nakalagay. Pero how do we describe it? We have, pag ganito ang question, you just don't give me the computation ha. You really have to give me the step-by-step procedure and how to prepare the solution. Okay. Low bat. Wait lang. Wait lang, ha? Sakto lang. Okay, let us continue. So what is now the step-by-step procedure based on the computation? Pag direct method, ganito lang. Step number 1, weigh. Ano yung na-compute natin? 53 grams. Weigh 53 grams of sodium carbonate. That's step number 1. Number 2, add enough, most likely our solvent plus in making our solution. Most of the time, it's distilled water. So add enough distilled water to dissolve. Ayan. To dissolve the sodium carbonate. And then step number 3, complete the volume. When I say complete the volume, you have to add more distilled water to complete the volume to, ano yung quota natin? 5 liters. 5.00 liters. So, ayan na yung yung ating step-by-step procedure in preparing the 5 liters of 0.1 molar sodium carbonate. So like if you're going to encounter this kind of problem in our quizzes or in our exam, you really have, aside from the solution, you really have to give me again the step-by-step procedure. So you have to compute first kasi how can you weigh a certain mole of substance? We don't have an equipment for that. So what we have is an analytical balance that will give us the weight. Okay? So again, weigh 53 grams of the sodium carbonate. Just like what you did has a, ano yung ginawa niyo? Sodium hydroxide. So di ba nag-weigh din kayo ng certain amount of sodium hydroxide. Nag-add kayo ng enough water just to dissolve the solid. And then afterwards, transfer niyo siya sa volumetric flask and complete the volume to 5 liters. Okay? Most likely, if you're going to prepare solutions in the laboratory class, what we are using is the volumetric flask. Okay? Next, state the process of preparing 1,000 ml of 0.5 molar sodium hydroxide. So this is actually almost the same problem. We just have different substance here. So kayo muna, let's have our participation in class. So please compute for this and then again state the process. So what I will be looking at the chat box is the process na. Okay? The process para maanad ta. Para pag medtech na mo puhon and you are required to make a certain solution, alam niyo yung gagawin ninyo. So kayo muna solve and then please give me the process sa chat box for your class participation. I'll wait for that. check nyo daw yung iba. Baka may typo lang sa answer. Wala nang nahabol. Okay. 2 minutes more. Okay. Let's answer this and let's read your answers later. Sige, state the process of preparing 1,000 ml of 0.5 molar sodium hydroxide. The same way of computing this. Start first with the moles. Okay, molarity, that's 0.5 moles per liter. Okay, that's 0.5 molar. You compute first for the mole. And then the liter of solution, 1,000 ml, that is equivalent to 1 liter. So you convert that to liter first. Cross multiplication, mole is equal to 0.5 moles per liter times 1 liter. So cancel the liter. This is 0.5 mole. So after computing the mole, we compute for the weight. So this is our formula. So this is 0.5 mole is equal to the weight over the molar mass. So sodium hydroxide plus, take note, that is our NaOH, a strong base commonly used in the laboratory. So we have sodium, oxygen, and hydrogen, one atom each times their respective, respective atomic weights. This is 23. Ay, nangyari sa kanya. 23. Okay. This is 16. And syempre, this is 1. So this is a total of 40 grams per mole. Okay? 40 grams per mole. Okay? This is weight. 40 grams per mole times the 0.5 mole. Cancel the unit. Ay, ano yun siya? Cancel the mole. So this is 20 grams of sodium hydroxide. So for the process, syempre, weigh 20 grams of sodium hydroxide, add enough water to dissolve this, transfer it in a volumetric flask, and add more distilled water to complete the volume to 1,000 ml or 1 liter. So let me back read first. Na natin yung sagot ninyo. Weigh 2 grams. Ay, 2 grams. Naiwan ang 0. That is 20 grams. Yeah, tama yan, Sheila. Naiwan yung 2 ata. Ay, I mean, naiwan ng 0. Bakit 2 lang siya? Typo yan, typo. Weigh 20 grams. Yeah. Bakit 10 grams ito? Kindly check your computation kung ano yung na-miss ninyo. Bakit siya either 2 grams or 20 grams. Let's see. Select data. One zone, paki-check nung 2 ang answer. Saan kayo nagkamali sa computation? Or talagang typo lang talaga yan? Typo. Okay. Sige. I'll give you a recording of this. 1,000. Oh, that's 1,000. Ngano? Asa? Kani? Ang volume? That's 1,000 ml. Nasa dupit din. 1 liter, 1,000, 0.5. Did I miss something? Wala naman. 1,000 ml. 5,000 na lang. 500? Why? 1 times 0.5, that's 0.5. And then 0.5 times 1,000. May computer. Ay, 0.5 times 40 day. It's 20. Nasa 500 ang ginamit. 500 ang nagagawa sa cycle. 1.00. 1 liter. 1 times 0.5 is 0.5, right? Oh, huwag mo siya multiply sa 1,000 ha. You convert the 1,000 to 1 liter. Pag 1 ang gamiton, 0.5 magawas. Huh? Pag 1, yeah. This is 0.5 ha. Sige, kindly check your answers as dapit sa computation mo nagkamali. But the answer is 20 grams. So tama yung iba, it's 20 grams. Kindly remind me about the recordings, if ever hindi ko siya mabigay. Sige, this is a new set of problems here. Starting from here, class. New set of problem na siya. Anong pinagkaiba nito? Let's try to understand the problem. A standard 0.01 molar solution of sodium ion, this is sodium ion, hindi ko lang nalagay as superscript yung positive sign. Again, a standard 0.01 molar solution of sodium ion is required for calibrating a flame photometric method for determining the element. Describe how 500.0 ml of this solution can be prepared from the primary standard sodium carbonate. Medyo complicated if first time natin siyang ma-encounter, but let's do this step by step para alam nyo yung inyong gagawin. So, again, ang given dito, kailangan natin ng 0.0100 molar na sodium ion. Okay? Sodium ion ito ha. Yan yung kailangan supposedly. However, class, please take note, in the laboratory, wala tayong chemical substance nag-exist na sodium ion lang talaga. Okay? Again, wala tayong chemical substance in the laboratory na sodium ion, purely sodium ion. So in this case, what we have in the laboratory is the sodium carbonate. So we still have sodium here, but it is in a compound na form, and that is again sodium carbonate. Okay? So, ano daw gagawin? Describe how 500 ml of the supposedly solution ng sodium ion can be prepared if we're going to use the sodium carbonate. Okay? Yan yung mga given natin. Ito yung target natin na solution. Concentration niya. And then the volume is 500.0 ml. But then again, wala tayong exactly sodium ion talaga in the lab. So what we are going to use is the sodium carbonate. And ito yung gagawin. First step. First step muna tayo ha. Compute. Let me just verbatim na lang. So, verbatim. Compute for the amount in moles of sodium. Sodium. Okay. So, may pumapasok kasi nakatabunan yung mga sinusulat ko. Okay. So, how do we compute for this one? We have here amount in mole. Ganito yung gagawin ninyo ha. Amount in mole is equal to the volume in liters times the molarity times the mole ratio. This is a combination of stoichiometry. Again, this is a combination of stoichiometry and actually molarity. So, concentration in molarity. So, paano natin mako-compute yung kailangan natin na sodium galing kay sodium carbonate? Una, kailangan natin gumawa ng 500 ml na solution. Okay? Oh, sorry. You have to convert this first. Take note, convert this first to liters. So, sa isang litro class, meron tayong 1,000 ml. Ba, mag-aungot dyan. Ano man yung akong pen? Diba na siya? Okay, this is 1,000 ml. Cancel the ml. This is 0.5 liters. So again, you have here 0.5 liters ng ano daw? 0.0100. Let me just use moles per liter, class. Ito yung target natin na gagawin, di ba? 0.5 liters. Pero dapat sodium lang yung kailangan. 0.01 dapat yung concentration. And kailangan natin ang mole ratio. Ano nga itong mole ratio? This time, hindi siya naka equation. Kasi yung mole ratio natin last time, nasa equation, di ba? Ang tinitingnan natin is the coefficient. This time, since ano lang siya, compound lang siya, ito lang din yung titingnan natin. Sa isang mole class, again, sa isang mole ng sodium carbonate, meron ka dyang makikita na 2 moles ni sodium. So dito siya sa baba. Kasi take note, itong 0.01 moles para ito kay sodium. So again, meron tayong 2 moles of sodium na makikita dito sa isang mole ni sodium carbonate. Okay? Compute muna natin. Take note, this is for the sodium carbonate. So cancel the liters, cancel the moles of sodium. Ang maiiwan dyan, moles ni sodium carbonate. Okay? So 0.5 times 0.0100 times 1 and divided by 2. Ang sagot dyan, 0.0 tatlo. 1, 2, 3. Okay. So, ang sagot dyan ay sa pen. Okay. So, that's the first step. We have to get first the amount in moles of sodium carbonate, taking into consideration our required concentration and volume of the sodium ion only. Okay? Na pag meron ka ng mole ng sodium carbonate, we can actually proceed with the next step. Next step is to compute for the amount this time in grams of the sodium carbonate. Using this formula, the same formula, moles is equal to weight in grams divided by its molar mass. So, ang moles na compute na natin kanina, 0.025 mole. And then, we are computing for the weight. The molar mass, I think, nag-compute tayo ng molar mass no, ng sodium carbonate kanina. And if I can remember it correctly, it's 106. But for the sake na step by step talaga tayo, let us do the computation again. This is 46. This is 12. This is 16. So yeah, that is 106 grams per mole. Okay, cross multiply. So we have weight is equal to 0.025 mole times 106 grams per mole. Cancel the mole. The weight here for our sodium bicarb, sodium carbonate lang pala, hindi pala bicarb, is 0.025 grams of sodium carbonate. So ito yung answer dito. 0.265 grams carbonate. Can I erase this one? I'll just have to write. Kasi the question is describe. So we need here still the step by step. So, ganun pa rin. Weigh 0.265 grams of sodium carbonate. Add enough distilled water to dissolve the solid. And then, oh, what's happening to the world? And then number 3, we can transfer this to a volumetric flask and complete the volume. What is our volume? Complete the volume to 500 ml. So, ayan na yung ating description. So, automatic class, ganito. If we're going to use 0.265 grams of the sodium carbonate and then complete the volume to 500 ml, automatic, we can get this one. Kasi ito yung target natin. 0.01 molar of the sodium ion. It's just that since we don't have a pure sodium ion in the laboratory, we will be using the sodium carbonate. But the amount here of the sodium carbonate na gagamitin will have this amount of the sodium. Okay? So kaya aside from computing the moles class and then yung simple computation natin sa moles kanina na diretsyo na, no? Moles is molarity is equal to moles per liter supposedly. Ganito yung pagbabago sa ating computation. We have to consider the mole ratio. Mole ratio lang naman yung nadagdag dito, di ba? Kasi supposedly, ang original formula natin na molarity is equal to moles per liter. Ganun pa rin naman. I-multiply natin si liters kay molarity. So, here is the liters. Ito naman yung molarity natin. Anong nadagdag sa computation? The mole ratio. So, gagamitin nyo lang ito for cases na meron tayong certain ion na hinahanap. Pero since walang specific na yon, walang pure na ion na nag-e-exist sa lab, we will have to use the compound containing that certain ion. Okay? So pakidagdag ng mole ratio in the computation. You have questions or clarifications? Wala. So I will assume nagkasinabutan na, ha? Assume pag walay pangutana. VF, volumetric flask. Okay? Don't forget, ha, kasi iba talaga yung yung like sa online class lang tayo compared sa we will do this on-site and then after that we will have the laboratory class kasi masasanay kayo na sa paggawa ng solution. Pero ngayon kasi since online, we are purely theory. So I hope sa paulit-ulit, hindi nyo na makalimutan itong mga computations na ito, molarity and normality. And at the same time, hindi nyo makalimutan na when you're going to make your own solution, you always use the volumetric flask. May scarcity lang tayo sa volumetric flask last time. That is why yung ibang grupo nag-improvise tayo. I mean, we used the graduated cylinder. Okay, can I erase the writings on the screen now? Okay. Sige daw, tingnan natin kung nasundan yung computation ko kanina. You try to solve this one. May time pa. Yeah, may time pa. A standard 0.002 molar solution of lead, this time it's lead ion, is required for calibrating a flame photometric method for determining the element. Again, yung required naman ngayon is lead ion. Ang concentration dapat is 0.002 molar. Now, describe how 1,500 ml of this solution can be prepared from primary standard, which is the lead chloride. Again, lead ion lang talaga yung ating gusto, kaya lang wala tayong pure lead ion in the laboratory, so we will be using the compound lead chloride. And then let's compute how much of the lead chloride are we going to use in order for us to prepare the 1,500 ml of 0.002 molar solution of the lead ion. Again, you try to follow what I did in the previous problem and try to solve for the required information there, required data. Okay. Okay. I'll wait for your answer, huh? Just I'll be back. Are you done? Elect time. So, I'll be doing the computation now. Just follow ha. Tingnan niyo kung ano yung natapos niyo na dyan. So again, step 1 muna tayo. Amount of PbCl2 muna. This should be in moles. Okay? So, amount in moles is equal to the liter. This is 1,500 ml. Convert muna natin. Isang litro, meron tayong 1,000 ml plus. So, this is 1.5 liters. Okay? 1.5 liters. Times the molarity. Where is that? This one. 0.002. Let's just use moles per liter times our mole ratio class. Sa baba si lead ha, since itong moles na ito para kay lead, so sa baba siya. Take note, 1 mole of lead kasi isa lang siya. Sa isang mole ng the whole lead chloride. So cancel the liters, cancel the moles. We will be left, dito na lang pala sa baba, with mole of the lead chloride. Where is my calculator? 1.5 times 0.002 is 0.123. 0.003 mole of the lead chloride. Ayan. And then, let's proceed with the step 2. This time, we are going to compute for the weight in grams na kung gaano karaming gagamitin natin na lead chloride just to achieve this one. So, moles is equal to weight in grams divided by its molar mass. Some moles, that's 0.03. Again, we are looking for the weight in grams. And for the molar mass, PB and then CL. 1, 2. What is the atomic weight of lead? 207. Am I right?
Yes po, ma'am.
Okay, that's 207. So this is 207. This is 35. So that's 70. So this is a total of 277 grams per mole. So cross multiply. This is weight is equal to 0.03 mole times the 277 grams per mole. Cancel the mole plus the weight here is 0.003 times 277 is 0.831 grams of lead chloride. Okay? So this is the correct answer. 0.0. This is lead chloride. Again, the correct answer is 0.831 grams of lead chloride. So for the steps, you have to weigh first the 0.0831 grams of the lead chloride. Syempre, add water to dissolve it. It's most likely water, distilled water. To dissolve the solid, transfer it to the volumetric flask and complete the volume. What is the required volume? It's 1,500 ml or 1.5 liters. So I think you got the correct answer, 0.831. Parang may nabali. Pero kindly check class the flow kung saan dyan yung na-miss ninyo in the computation. Okay? So itong 0.831 grams class ng lead chloride na ilalagay natin sa 1,500 ml, will be a representative. Meron yan siyang 0.002 molar ng lead ion, which is ito yung hinahanap talaga natin in the problem. Okay? Questions for this one? I hope you followed class the steps here to compute. Again, gagamitin natin ito for the computation of the ions. So, dadaan muna tayo sa compound nila kasi wala nga tayong pure ions in the laboratory. Okay? So, for the succeeding problem, this will be your assignment. I'll just give you a submission bin sa Schoology for this. You try to answer. You just try to answer the next problems. This one, did I already give you a copy of this? If wala pa, I'll be posting this para may copy kayo. This is number 1. Karugtong ito class ng ito. Itong una nating sinolve, the sodium carbonate. Karugtong niya itong assignment number 1 ninyo. Wala pa pala. When deadline? Next week. Sunday, I mean, 11:59. So you'll have more time to solve for this. Karugtong niya itong sodium na kinumpute natin sa previous problem. This is number 1. And then this is number 2. Pero itong sa number 2 class, standardization na ito. So pag sinabing standardization, titration problem na. Pero we are going to use the same formula for both molarity and normality. Okay, this is problem number 3. And medyo mahirap, pero you just try to answer problem number 4. Okay, and then that's the end. So, 4 yan siya. And then before the quiz next meeting, we'll try to answer your assignment. Okay, any question or like clarification?